Hello, everyone. First of all, thanks for attending this session. My name is Mateus Cichelero. I'm representing here today Munai Health, which is a health tech here from Brazil. And well, the idea here is that I present one of our latest projects called Enhancing Antimicrobial Stewardship and Low and Middle Income Countries through AI-driven tools, focus on conversational agents and reg architecture. So the idea here is that this is the main ideas behind the project. This project was received a grant from the Bill and Melinda Gates Foundation last year, and we are super proud of what we are building and applying at Brazilian hospitals. And the idea is to share and also to bring some thoughts from the development of this application. So the agenda, it will be a super quick talk. I'm going to start introducing the problem. Then I'm going to talk about the intervention of what we thought that could be a good solution for at least to help to tackle this problem. And for the last part, I'm going to talk about the methodology, the architecture that we use, what are the tools, what are the workflow for the application, next steps, and then the conclusion. So the most important part of all this project and the application is the problem. So what we are talking here is about antimicrobial resistance. It's a huge problem globally, not only in low and middle income countries such as Brazil, but just to mention some numbers, the World Health Organization mentioned that around 4.5 millions of deaths were induced by antimicrobial resistance only in 2019. In terms of costs, that could bring up to $1 trillion by 2050. So this is a huge global problem that we have today. And the idea here is that it's even worse in low and middle income countries that, such as Brazil, for instance, that are starting to apply antimicrobial stewardship programs, starting to digitalize all the process inside the hospitals. So we have even a worse situation here. And the idea is that poor antimicrobial stewardship programs, the poor adherence to those programs contributes to antimicrobial resistance, and that contributes to more costs and to more deaths. Our hypothesis here in this project is that AI-driven tools using LLMs, for instance, can improve the correct use of antibiotics inside hospitals and the correct adherence to antimicrobial stewardship programs. So that's what we had in mind when thinking about the solution and thinking about the architecture that I'm going to show you. So the intervention, what we thought about being a good solution to that is to, first of all, develop a conversational agent to provide physicians and clinical staff with real-time guidance on antimicrobial therapy. The idea here is that the hospitals and even the government, for instance, here in Brazil, we have our unique system for healthcare, SUS. They actually have guidance, they have guidelines, they have validated protocols for the correct use of those medicines, for those antibiotics. But the main complication here is that in a day-to-day, the adherence to those programs, to those guidelines are not great. Inside hospitals, there is a chaotic system and environment, and the idea here is to use technology to try to stop the gap between and democratize the assessment to that information. So to do that, we would be constructing a conversational agent and also use those agents to not only interact with those guidelines, but also to the EHRs, to the electronic health records in the second phase of this project. So the idea here is to bring those data closer to the physicians and to the clinical staff. This is a project that I'm talking about. It's not a product yet. So we developed that in 2 phases. Actually, right now we are finishing the phase 1, where we develop this conversational agent through a chatbot application. And the idea here is to transform the guidelines for the correct use of antimicrobial antibiotics from a partner of ours at the Albert Einstein Hospitals in São Paulo, Brazil, which is one of the biggest hospitals here in Brazil, and to also conduct validation with them, with their clinical staff. And for phase 2, we are aiming to scale that using applying those same kind of constructions using data from EHRs from our clients. Today, Munai has more than 40 hospitals, public and private, here in Brazil, and we are trying to bring that stewardship also to their own EHRs as well. So how we did that, how we construct that application. The idea here is that to develop a conversational agent. To do that, to be able to bring a solution to those physicians and to make them interact with their own guidelines and protocols, the better, the most suitable architecture was actually use RAG, retrieval augmented generation. And through that, we were able to apply those guidelines in a day-to-day in a conversational way. So the idea here is that the antimicrobial guidelines and protocols, we are considering that as a knowledge base, and the choice of RAG was made, of course, because in that way they were applying and only considering their own private data. So problems such as hallucination and other problems that comes from naturally from large language model, we would try to mitigate that using a RAG architecture. Also, the main idea here is that each hospital in each institution has its own guidelines, so that is also very adherent with our suggestion of our purpose here. Just to mention some of those protocols and guidelines, I brought some examples for that. These are some of those documents from the Albert Einstein Hospital. These are open documents that you can search at their own website. And the main idea here, it's all in Portuguese, of course. That's the language that we speak here in Brazil. But the main idea here is that inside each document, we don't have a standardization. We don't have a pattern of how that information is written. So, for instance, in this first slide, we have a whole workflow flow of information where we have different categories of information. We have, for instance, some symptoms here for a specific disease, some checks that if the patient has sepsis, for instance, if that is yes, then you go from one side of the flow. If that's no, then you go to the other side. And we also have the treatment suggestion that was validated for Albert Einstein Hospital that brings different antibiotics depending on the clinical context of those patients. So you can see that is a work chart, flow chart inside an image, inside a PDF document. So very unstructured data, right? And I also have more examples here. Here's the same idea we have in this table, which is an image by the way. We have different bacteria agents here, antimicrobials, antibiotics, some alternatives in case of allergy, for instance, and the length of the treatment that is suggested in each case. So depending on the disease, depending on the clinical status, you could have different structures of data that could suggest a specific treatment. That's the most challenging part of this kind of application, because we have to have a way to construct, to represent this data inside the application as well. And just to finish those examples, here we have something very special about one of those protocols, those guidelines, where we have, this is a pneumonia guideline, where we have a clinical score for criticality for the patient called CURB 65. This is a score that is calculated based on the clinical status, clinical context of the patient. So that is one of the examples where we had to model that inside of our prompt, inside of our application, being able to calculate scores as well, and then bring that to the LLM to use that information as context as well, and try to retrieve the best scenario for treatment, for instance. So that's just a quick note on how those documents can vary, and it is in Portuguese, which is another challenge, being that the bigger LLMs today are still aiming for the English language as well. So the architecture, the workflow that we construct here is basically a standard RAG workflow, where the physician or the clinical staff makes a question about a patient. The whole idea here is that the physicians input a clinical vignette or clinical context and ask about a specific treatment, for instance. Though that question is embedded as a vector, super normal for that kind of application. And then we already have that vector store, vector database, where all these different protocols and guidelines are already represented. And we perform a similarity search, trying to connect that question to the relevant documentation from that specific institution or hospital, for instance. From that, we work a lot on our prompt, including, basically we have two flows that go from there. We have the relevant data, the guidelines and protocols and chunks from those documents. And the idea here is to ask, can the question be answered with those guidelines chunks or documentation? If the answer is yes, then we go through a standard RAG flow, where the LLM only considers data from those guidelines. And if the answer is no, for instance, I'm asking about a virus disease that is not in the realm of antimicrobial or stewardship, then the LLM suggests a response from their own training with source material indication. So it can be general as well, relying on the LLM answers as well. So from that, we construct the final answer, and we have a whole human in the loop feedback, where we are right now getting more data to also fine tune those LLMs as well. So that's the basic workflow. We also have clinical validation in this project. So the idea here is to count on our partner at the Albert Einstein Hospital, where 20 physicians will evaluate different clinical cases, clinical vignettes, without using the application, and using the application in a simulated clinical study kind of scenario. So the idea here is that we are going to collect different data from that study, including demographics from the physicians, the comparison and the adherence from the therapy decisions based on the clinical guidelines, knowledge assessment with multiple choice questionnaire, usability assessment as well, because we want to know if the application is suitable to use in a day-to-day scenario inside the hospitals, and also a self-declared confidence measure as well. Just to show you a little bit about the application itself, it's basically it's very similar to a ChatGPT interface, where we have the context that the physicians will use this tool for. We have the historical conversations from previous conversation. You can also start a new conversation about a new patient here. And that's the basic scenario here. And for just to point some examples of use, the idea here is that the tool can um, can answer about clinical decisions, about therapy mainly, but also about some questions about how it was trained, what are the protocols and guidelines that they support. For instance, this question is about which protocols were you trained on, and the assistant answers the list of the protocols, such as pneumonia, um, treatment of diseases in ICUs sectors, meningitis, for instance. So it lists all the guidelines that they support. And just to mention one clinical example here, we basically ask about a patient, a woman with 70 years old, that goes to an emergency room in a hospital with fever, with mental state that is declining. And after some exams, the diagnosis is meningitis, right? So it asks about the correct treatment based on clinical guidance from that institution. So the assistant basically says that it's based on its response on the meningitis specific guidelines from Albert Einstein hospitals, and it brings all the different antibiotics alternatives in case of allergies, and also the length of treatment and the reference that the guidelines are based on. So that is just a example of how those answers are bring to the clinical staff and physicians. And we also have a whole different application for analyzing those data, or analytical dashboard, where we can have how many active users we have, how many tokens are we using the last month, for instance, how many feedbacks, positive, negatives that we have in time. So we are trying to construct not only the results for this project, but also a product from that, and trying to scale that product. So just to finish up, our next steps is we are actually this week are gathering the results from that study with our partners at Albert Einstein Hospital. And the idea here is with the publication, we are going to try to scale that for different hospitals with a lot more data on different protocols and guidelines as well. And for the second phase, also to connect that with our EHR's database. We are using HL7 Fire for that, and we are pretty excited to also bring that same kind of application to interact with health records systems as well. And to conclude that, we are trying to bring the power of AI to tackle this huge problem that is antimicrobial resistance in lower and in middle income countries such as Brazil, that we are starting to test. And the main goal here is to improve guidelines adherence, and also to bring more knowledge among those physicians based on their own validated guidelines and protocols. And we are sure that can have a huge potential to save lives and also to reduce costs as well. That would be it for the presentation. Thank you again, guys, for attending, and I'll be answering some questions in the next few minutes. Thank you.